Hello everyone. Today we're going to talk about differentiation rules. So we found some derivatives already, but we're going to focus today on some tricks so we don't have to do as much work as taking the limit as h goes to 0 of f of x plus h minus f of x divided by h. We're going to use some tricks to find quicker derivatives. So I'm going to give you a bunch of different rules. Okay. First is derivative of a constant. So if we have f of x equals c, where c is a constant, and f prime of x is 0. So the derivative of a constant is 0. Okay. Let's say we have a power. Okay. So if we have a power, we call this the power rule. If I have, let's say, if f of x is x to the n, so here n can be absolutely anything. It could be a positive integer, which is a lot of times a little bit easier, but it could truly be anything. It could be rational, irrational. The power rule will apply. So if we have just some power, the derivative, we multiply by that power, and then subtract 1 from that power. So we say nx times n times x to the n minus 1. So that is our power rule. So let's do some examples. So let's say I have x to the third, x to the 2 over 3, x to the root 2. Let's do 1 over x to the fourth. Okay? So let's use our power rule for these. So we have x to the third. What we want to do is subtract 1 from the power and move the original power down. So we have 3x squared. So we move the 3 down and subtract 1 from the power. Okay? Do the same thing for the next one. We bring the power down. So we have 2/3 x. And then we want to subtract 1 from 2/3. That'd be minus 1/3. Okay? Same thing for root 2. You bring the root 2 to the front. We have x. We subtract 1. We don't know what root 2 minus 1 is, but that's okay. The power rule still applies. This next one, it might be a little easier to rewrite. If I have 1 over x to the fourth, remember this is equal to x to the minus 4 if we consider our exponent rules. So if I have x to the minus 4, I use my power rule. I have minus 4x, and then we subtract 1 from the power, so we'd have minus 5. If we want to, we can write it back as minus 4 over x to the fifth, but that's not necessary. Let's do one more rule on this slide. Let's say derivative, and we call it constant multiple rule. Okay? So if f of x, let's say, is c times g of x, let's say, so just some constant times the function, then f prime of x is c times g prime of x. So we can think about this almost as we can ignore the constant there. So we can take the derivative of the function, and that would be our derivative. So little example of this one would be if I wanted to take the derivative of 3x squared. So what I can do is for f prime, I ignore the 3, and I just take the derivative of x squared. The derivative of x squared is 2x, and then I can multiply them together, so it'd be 6x. So the idea with the constant multiple is we ignore the constant, take the derivative, and then we can just multiply by the constant. Okay, so we have some more rules. We can use the sum rule. So the sum rule is if we have two functions. So let's say we want to say f prime of x is equal to, let's just say u and v for right now, make it a little bit easier. So I have u and v are two different functions. Sorry, this should be f of x, not f prime of x. We want to find f prime of x. So f prime of x would be u prime plus v prime. Okay? And I just want to introduce another notation we might see. Sometimes people write if we have f of x is equal to, we'll use u plus v again. It's the same thing if we write d dx. So we say the derivative with respect to x of, in this case, it's u plus v. So we could rewrite this as du dx plus dv dx. So you might see this notation as well, but I normally use the prime notation. I like it a little bit better, but this is just telling us what we're taking the derivative with respect to. So that's just a little extra piece of information. So if we want to take the derivative, let's say, y equals x to the third plus 4/3 x squared minus 5x plus 1. If we take the derivative, we can take it term by term. That's what this sum rule is telling us. So clearly, adding and subtracting would be the same in this case. I just treat the sum of a negative number instead of calling it subtraction, but it would work the same way. So term by term, we differentiate. We would have 3x squared. We'd have plus 8/3 x minus 5. And then 1, the derivative is 0. Okay. Another rule we have is the derivative of e to the x. So the derivative of e to the x is one of our easiest one. So if we have f of x is equal to e to the x, f prime of x would just be e to the x. So our next two rules are for some of our other operations. And we have what's called the product rule. And then we'll do the quotient rule. So the product rule, I'll write with the prime notation. So if we want to find the derivative with respect to x, let's say d dx of f times g. So I have two functions being multiplied together, and I want to take the derivative. This is the same thing as fg prime plus gf prime. So the order here doesn't matter. We find the derivative of both functions and then plug them in. So, for example, let's say we have, let's do a little tricky one. Let's say we have 1 over x times x squared plus e to the x. So what I'm going to do is I'm going to break them into two functions, f and g. So f of x would be 1 over x, and we're multiplying it with g of x. And I want to find the derivative of both. So f prime of x, remember 1 over x is the same thing as x to the minus 1. So we could use our power rule. We move the negative to the front, and then we add 1 to the power. So we'd have minus 1 over x squared. Or you could think of this as minus x to the negative 2. Minus x to the negative 2 is the same thing. So if you write it that way, that'd be okay. G prime of x here, term by term, is 2x plus e to the x. And then we can just go ahead and plug that back in. So f is 1 over x, and then we multiply by g prime. So we have 2x plus e to the x. We're going to add it to gf prime, so x squared e to the x, and then times f prime. Sorry, it was x squared plus, make sure I write that down right. Our g was x squared plus e to the x. And then we're going to multiply it by our remaining one, which was minus 1 over x squared. So, just to highlight it, so we have 1 over x, which was our f of x, so this is f times g prime, plus x squared plus e to the x was g, and this was f prime. So we had g times f prime and f times g prime. It doesn't matter the order you do them since we're adding them, as long as you have f times g prime and g times f prime. Okay. So I'm going to have you try another example. Let's look at y equals e to the 2x. So at first, this might not look like a product rule, but remember our exponent rules. This is the same thing as e to the x times e to the x. So that was an exponent rule there. So now we can use our product rule. F of x is e to the x. G of x is e to the x. So then f prime is e to the x. G prime is e to the x. And then we can go ahead and plug that in. So they're all the same thing, so it doesn't really matter. So we have e to the x times e to the x plus e to the x times e to the x. So if we multiply these together, we're going to end up having e to the 2x. And then we have 2 of them, so we have 2e to the 2x. So that's just a little creative example. Okay, let's try the quotient rule now. So the quotient rule we have to be a little bit more careful with. All right. So for the quotient rule, we say the derivative of f divided by g is equal to gf prime minus fg prime. And then we do it divided by g squared. Let's look at an example. So if we have t squared minus 1 over t to the third plus 1. Let's pick f of x is our numerator, t squared minus 1. G of x is t to the third plus 1. Let's take our derivatives. So 2t, g prime is 3t squared. So we have everything we need. We can go ahead and plug it in now. So let's call this y. So we can call this y prime. So y prime would be g times f prime. So g is t to the third plus 1 times f prime is 2t. Then we do minus f, which is t squared minus 1. Okay. And then we have times g prime, which is 3t squared, over g squared. So t to the third plus 1. And I'm perfectly happy if you leave it there. No reason to multiply that all out. You probably can multiply out the numerator pretty easily and do some simplifying, but this is what I'm looking for here. So last thing for our derivative rules I want to talk about today is higher derivatives. So higher derivatives just mean there might not be just a first derivative. There might be 4 or 5. So let's look at an example. So if I have y equals x to the third minus 3x squared plus 2. So let's take the derivatives. We already know how to do y prime. Y prime is 3x squared minus 6x. But we're also allowed to keep going. So if we write y double prime, that means second derivative. We just take the derivative like we did again. So I'd have 6x minus 6. I could keep going. The y triple prime would be just 6, because 6 times the derivative of x is 1, because it's x to the first. So x to the 0 is 1 when we move the 1 over. So derivative of x is 1. And then derivative of 6 is 0. So that goes away. So we have 6. And then we can write, after we get to the third, we can just start writing in the number. So y to the fourth. So the fourth derivative of y is 0. So that implies when we have y to the n, we get 0 when n is anything bigger than 4. So 5, 6, 7, and so on. Take the derivative of 0, we just keep getting 0. So we'll come back to that when we talk about some velocity and acceleration, but we can take more than one derivative as well. I hope everyone has a great day. I'll see you all next class.